Hello everyone, we're going to talk about precession today. In the first slide you can see that we're comparing the Earth to a spinning top, and the best thing to do now is just go and watch a little video of a gyroscope and the precession of a gyroscope. So go and watch that and then come back to this, please. Now in the video you should have seen that at the start when the spinning top had its axis, which we'll call this line here, and that's like the axis of the Earth, when it was pointing directly at the ceiling constantly, you wouldn't have had any precession, but as it starts to slow down you would see the precession, which would be the wobbling of it quite clearly. And that's what the Earth is doing. It's actually caused by the gravity from the moon and from the sun, and the reason it happens is because of the bulge of the Earth. The Earth bulges out round its equator. First suggested by Newton that precession could be caused by gravity, but it was known a long time before that there was precession. So precession is the wobbling of the axis, and it goes around in a circle, in a cycle, and a full cycle takes about 26,000 years. So, you know, it takes a while, but in the grand scheme of things, I suppose it's not that long. So we can look back 2,000 years, 3,000 years, and work out where the stars would have been. Right now, if you look directly up from the North Pole, you're pretty much pointing towards Polaris, but that's not always been the case, and it won't always be the case because of precession. So, I'd like you now to go and watch the second of two videos, which will talk about Earth's precession and will explain it far better than I'm trying to here. So, right now, as I've said, the North Pole points directly toward, or pretty much towards Polaris, slightly off. But about 5,000 years ago, it was pointing towards Tuban, which is in the asterism of Draco. And about 12,000 years from now, it will point towards Vega, which is the really bright star, and it's the brightest star in the asterism of Lyra. So it's shifting, and from here back round 26,000 years. Now the Earth's axis doesn't change, so if I go back here, the Earth's axis will always be 23.5 degrees to the ecliptic line. This is the ecliptic line here, which is a line that points directly towards the Sun. But the wobble just rotates it around. Okay, this is the third of three slides here, and this is how we can use precession. Now in your exam, they might ask you a simple question about what precession is, but more likely you'll get a question asking you to do some sort of calculation based around precession, which is why I've attached some of the calculations for you to try into the class charts there. So certain monuments were built and they were aligned with certain stars, and the dramatic picture there on the left is the pyramids aligned with Orion's belt. So they might not be aligned anymore because the stars are not in the same position as they used to be, because if north doesn't point towards Polaris, it'll point somewhere else, then everywhere else points somewhere else. So we can use that. That's really useful to us, because if we can work out what stars they were meant to be aligned to, and we know Earth's precession rate, which is 1.4 degrees per century, so we can work our way back. So if they're 1.4 degrees out, then we know they were built a century ago, 100 years ago. The example in green there, if they were 28 degrees out, we know they were built about 2,000 years ago. So it's a nice way of dating these things and when they were built. So as I've said, the calculations tend to be based around this idea of the rate of precession, 1.4 degrees, so working back, seeing how long ago it was built, and just do your best with them, and then email me if you've got any problems with the maths. But that's it for precession. Thanks very much.